All right, guys, so we are going to spend today, I'm going to go through all of the factoring. So we'll review like difference of squares and some regular factoring. I'll probably go a little quick through those. But then we're going to move into harder factoring. We're going to, well, let me rephrase. Not necessarily harder, different. Different. Not today. Next week, yes. Next week. It's not that bad. All right, so we're going to look at difference of squares. We're going to look at some regular factoring that we've done, and then we're going to also look at factoring when there's 4 terms, which is we have to use grouping, and then we're also going to look at factoring when it's x cubed. So we're going to look at sum and difference of cubes. Okay? Kind of, yeah. So we're not solving today. Not solving. I used to teach it all at once, like you'd factor and then we'd solve. But then it was bad. It was real bad. So now we're just going to work on factoring, get that down, and then next week we'll move into actually solving them. Okay? So we're just factoring today. So always remember to factor out the blank before doing any other factoring. GCF. Why is my line so long? Greatest common factor? Yeah. So if you're one of those people that it bothers you that that line is so long, you could write greatest common factor in there. But GCF, greatest common factor. Next, you have to look at the polynomial that remains. So this is like a big deal that you can recognize what's happening with it. So you have to look and see what's left. Is it quadratic? What's quadratic mean? Squared. Squared. So is it quadratic? So then it's just your normal factoring that we've always done. Is it quartic? What's that mean? To the 4th. That one actually acts like the pattern that we've already done, and I'll explain that in a little bit. Is it factor by grouping, which will be 4 terms, not 4th degree, 4 terms, or is it the sum and difference of cubes? What's a cube mean? X to the 3rd. So you have to be able to look at what's left to figure out which style of factoring it is. All right, so use guess and check to factor quadratic trinomials. And then we do this when we're looking at when they are quadratic. Okay, so if it's quadratic, we use our guess and check method. But before I can determine what it is, you got to take out the GCFs. So don't look at the original problem when we're starting determining things. Take out the GCF first. So number 1, GCF. Okay, so we'll take out the 2x, and then we're left with x squared plus 4x plus 3. I'm sorry. Thank you. All right, so then once you pull out GCF, now let's look. What do we have left? Is it quadratic? Is it cubed? Is it quartic? It's, no, just what's left inside. That's quadratic. Quadratic is where we're doing our guess and check. That's the normal way we factored. That's all we know at this point. All right, so 2 sets of parentheses. Good. X plus 3, x plus 1. And we are just factoring today. Yep. So should these be that hard? No. Let's skip 2. Let's jump to 3. GCF? Good. Negative 2x squared. Remember, if that first one's negative, we always take that out. So watch your signs then. What do we have left? Positive 4x squared. Good. Plus 9x minus 9. Yeah, we always got to watch those signs when you take out that negative. All right. What are my signs? All right, he said 4x minus 3 and, what did you say, x plus 3? So negative 3 plus 12. Yep, he's right. I don't want to spend all of our focus here because we should know how to factor these, right? You may need a moment to kind of play with the numbers, but we can factor those. All right, so that's a recap. We've done this. Moving on. Moving on. Difference of squares. Do we remember these? They're my favorite. My favorite. But before we do anything, GCF. 3x. What are we left with? Good. And it's quadratic, so we're going to keep going. right, so how did that finish factoring? Good. You cannot, because it has a different meaning. If I'm just asking you to factor, I want to actually see every single factor that is there. Now, when you're solving, could you write x equals plus or minus 5 halves? Yes. Yes. I cannot, because these are not exactly the same. Yeah, one's plus, one's minus. If they were both the same sign, then yes, you could have. All right, let's skip 5, jump to 6. GCF? Good. Watch your signs. What's left? Can I factor that? 49 is a perfect square, but 1's a perfect square. What's wrong with it? There's a plus sign. Does that factor further? No. In this case, this one would stop there. So just beware, difference of squares has to be a minus sign in between. Okay? All right. So that's a refresher on all the old stuff. So what if it isn't quadratic? What if it's not an x squared? Can you still factor? Of course you will. So we are going to factor cortex, so x to the 4th, like you factor quadratics. Quartic? Oh, quadratic. So the entire last chapter we did? Oh, no, the whole, like chapter 4 was all quadratics. Quadratic formula. It's all right, we all have those days. It's okay. All right, so if we look at this, right away we'd always look for GCF, but is there one in this problem? There's not, but it's not x squared. Everything we have factored up to today had to have been an x squared, so then I can go x and x. All right, but I'm telling you, we treat these just like we do quadratic ones. So let's kind of attack it the same way. What would your signs be? Plus and minus. Instead of x and x, we're going to go x squared and x squared. It's an extra exponent. Now, when we get into solving, though, it makes a big difference. All right, and then, good, plus 1 and a minus 4. So what are we feeling? Okay. Look at what you have left. Either of those factor even more. Yeah? Why doesn't this one factor more? It's positive. This one, x squared minus 4, that's a difference of squares? How does that one factor? There you go. And then don't forget you still have the x squared plus 1. So we treat cortex like we do quadratics. Because again, if you would check this, right, if I check this inside would give me 1x squared, outside would give me negative 4x squared. So together that gives me a negative 3x squared, which is what I do have in the middle. So it works out. All right, so number 8. No. There's just going to be a here factor. And you have to, we're going to get some practice next week where I literally am going to give you a page of problems and make you sort them by which method they are. Just so you get used to seeing it. But how easy is it to recognize the quartic ones? There's an x to the 4. Yeah. Okay. So how about number 8? There's no GCF. That's what I wanted you to notice first. Good. X to the 4th. So I'm going to treat these just like the x squared ones. Treat them just like quadratics. So set up my parentheses. What are my signs? All right. Options for A. We got what? 1 and 18. 2 and 9 and, all right, and then we just have 1 and 2 over here. So what do you want to go with? 6 and 3? So 6x squared and 3x squared. The biggest thing is just going to be remembering that you need that squared on there because it was a fourth. Then 1 and 2 or 2 and 1? 1 and 2. So if I check, that gives me 3x squared. Outside gives me 12x squared, which is 15x squared. Do either of these factor further as difference of squares? No, they're both plus signs. That's my one red flag. And none of them are actually perfect squares. So I'm done there. Not so bad. How about number 9? No GCF? Oh, there's an extra variable in there. What the heck do I do with that? If you put it on the outside, you've implied that it's a GCF and it goes out of all of them. Well, let's just go step by step. What are your signs? Options for A. 1 and 1, and so it's going to be x squared and x squared. Options for C. 1 and 5. And then there's a y to the fourth on there. Y squared and y squared. So 1y squared and 5y squared. Because if you check them, that'll give me x squared y squared. Outside will give me 5x squared y squared, which is 6x squared y squared. So they come together once you can go ahead and check and multiply those together. No, we are not. We are not. That's about as extreme on the variables as we'll get. Yeah, on variables. So how do we feel about quartic so far? Not bad? All right. So we're going to factor, what do you recognize with this problem? What type of problem is this? It's quartic. But what type of quartic is it? It looks like difference of squares, right? So we factor quartic difference of squares like you factor quadratic difference of squares. So again, the biggest thing is just recognizing I have a to the fourth power, so when you split it apart, it becomes squared and squared. Bless you. Yes, and I love that you prefaced that the way you did. He said it so as long as there's no x as a GCF, then if it's a 4, it's quartic, and yes. But you always want to pull out the GCF first, then determine what it is. So when I give you next week this activity where I'm making you sort by which type it is, what should you do first on every problem? Take out the GCFs first, then look at them. It makes a big difference. So on the first one, how's that factor? Good. 10x squared plus 3, 10x squared minus 3. Does the minus 1, does that keep going? Is that another difference of squares? No, 10 and 3 are not perfect squares. All right, number 11, GCF? 7. Right, the obvious. We don't think of the easy stuff, right? So that'll give me 4x to the fourth minus 1. Yeah, now they're both squares. So how does that one break apart? Good. You could have written the minus first. I've been okay. Ooh, does that one keep going? No, it's got a 2 on there. 2 is not a perfect square. Last one? GCF? Nope, no GCF. But do you recognize that they're squares? How does that one factor? Good. Quartics. Hard stuff? Not really. Yeah. we gotta remember an extra little 2. Now, thinking ahead, we're not solving today, but thinking ahead, how's that change when you go to solve things now? What do you have to do with all of your answers? You have to do the square root of them. Yeah, right? You would normally like subtract 1, divide by 2, so you're like, it's -1/2. You'd have to take the square root of that. That's going to change your answers when we get into solving. Yeah. The square? Yes. Yes. When you get into solving, yeah. And it's okay. All of that rationalizing the denominator and all of that will come back. You're going to set them equal to 0. You would get the x squared by itself, so subtract the 1, divide by 2, and then you take the square root. And we'll get into that next week. It'll come back to you. Okay, so let's go ahead and look at something totally new. Cortex were like what we've done before, but now, totally new. Now, some of you, I think, learned how to factor in general. Like we do guess and check in here. I think some of you learned it by doing a grouping method. So this may look familiar to some of you. So factor by grouping. This is when you have 4 terms. So how easy should these be to recognize? Very easy. Everything that we factored up till now has either been 2 terms for difference of squares or 3 terms when we did guess and check. Now we have 4 terms. So step by step, 4 terms is called factor by grouping. You will literally group the first 2 and group the last 2, like put parentheses around them. Factor the GCFs out of each set, and then you'll have a common factor that you'll put in one parenthesis, and whatever's left over goes in the second one. So when you're done, you'll have 2 sets of parentheses, just like every other factoring we've had. And let me show you how it works. I totally missed a page. There we go. So, number 13. See how there's 4 terms? All right. Group the first 2. Group the last 2. That is not factored. I have students every year who are like, yeah, I'm done, factored. No, that's not factored. What's the GCF in the first set? Yeah. It's attached to the 18. Yep, always keep that with whatever it's next to. Good question. So good, x squared, so 2x plus 1. GCF in the second set? -9. That's why it's important to keep that so you know to take out the negative. And what do we have left? Plus 1. If you look back at the steps, what did I tell you there would be? A common factor, and then whatever's left over. Look at what's left here. Look at this. Is it the same? Yeah. That should always happen. If it doesn't, either A, it does not actually factor by grouping, because not everything with 4 terms does, or B, you did it wrong. I can tell you right now, for tonight's homework, they will all work. Okay, so if you don't get that, you did something wrong. Christian? No, my common factor, you would tell me, is 2x plus 1, right? That's my common factor. And then what's the leftovers? Now, of course, I started with a trickier one for you. Look at your final answer there. Is anything factor further? X squared minus 9. What's x squared minus 9? X plus 3, x minus 3. They were just the leftover pieces. This and this. It's the stuff that's not the common factor. And then 2x plus 1. Yeah, no, take a minute. Take it in. That was, okay, I pulled out a GCF, pulled out a GCF. Are you okay with that? The part that is in your parentheses, if you did it right, should be the same. That's the common factor. That goes in this one. And then the leftovers, the stuff that was not the commons, those are your GCFs. That's the leftovers that go here. Yeah. Good question. No, good question. All right, look, guys, let me try to address what she just asked, because this is where a lot of people mess up, because they want to do exactly what you just asked me. So let's go back here. Are you guys okay if I call this whole piece y? If I just call that a y? Hang with me for a minute. So technically I have x squared, and that's a y, minus 9, that's the same thing. I'm going to call that a y. Just hang with me. It's easier for you to recognize what I'm doing here. If I asked you to factor that, what would you do? You take out a y, and you'd be left with x squared minus 9. Now, what did I tell you y was? It was 2x plus 1. So really what I did is I factored out the GCF from that. The GCF technically was 2x plus 1. So I factored that out, and I was left with the x squared minus 9. Yeah, because you're like, I don't get how to pull out a GCF of a whole parenthesis. If I did this, though, you're like, yeah, I take out a y. That's exactly what I did up there. What? Yes. Adrian, can you hit the door for me, please? Thank you. Oh, I forget one, didn't I? All right, so let's look at 14. 4 terms. So let's group the first 2, group the last 2. GCF in the first set? Good. So I get x minus 2. GCF in the second set? Negative 10x. What do I have left? X minus 2. Holy crap, everybody see it? What's the common factor? What's left over if you take that out? Yes, I can. Are there questions to there before I do the last step? Okay, but no. Good, Izzy. You see the GCF sitting in here? Yeah, you can take a 2x out of that. So x squared minus 5. And then I still have this. I'm just going to throw it over here at the end. Now, why did a GCF show up in that parenthesis? Look at your original problem. Look, we didn't take the GCF out of the original. Now, you have 2 options. One, you can take the GCF out first, and then you don't have to worry about that. I will tell you, typically, when on just the grouping, if you take the GCF out first, it gets in the way and people don't know what to do with it. Because then you're doing like the grouping and you're pulling stuff out, and then they're like, what do I do with that thing? He just kind of hangs out at the end. So for grouping, that's the one time, if there's a GCF, I usually pull it out at the end. To me, it just makes it easier. Let's do another one. So let's group first, though. Let's make sure we don't forget to write that down. What's the GCF in the first one? 4x squared. Good. GCF in the second one? Negative 1. Leave me with x plus 3. Common factor? Leftovers? Does that go any further? Mm-hmm. How's that factor? 2x plus 1, 2x minus 1. Now, for whatever reason, when I created all this, I've made like every one go a little further. They've been different to squares or GCF, or there's something else going on. Does that always happen? No, it doesn't. But I wanted you to see it, because what happens is if I only did like one where something happened, you kind of forget to look for it. Now, one other thing I want to point out, we took out a negative 1 from that set, right? What would have happened if there wasn't a negative there? Like, do you have to take out something? Yes. Could that something be a 1? Yeah. Now that's the thing a lot of students mess up on. Like, let me just throw something out to you at random. Let's say I had, I don't even know, 3x, x plus 2. So that was the first part. And then the rest of your problem had plus x plus 2, right? And that was what you had grouped. What would you take out of that? You'd have to take out a positive 1. Does it change it? It doesn't. But why do I have to take something out? I need to have, I need to have this and this be in my other parenthesis. I would need to have an x plus 2 as the common part, and then I got to have 2 pieces to put in the other one. Okay, so I want to make sure we're clear. This one we took out a negative, so I think we would have been okay. But when it's a positive one, people are like, I don't even, there's no GCF. You've got to take out something. Mm-hmm. That's okay. No. But I will tell you, most people won't put the +1. If you can do it, that's fine. Okay. You guys want to try 16 on your own? Try 16 on your own. All right. What do we do? You're getting a headache? Why? This? Just because they're variables? I'm sorry. Group the first 2, group the last 2. GCF here is an x. C minus 2. I don't know. It's got a mind of its own. All right. Common factor. C minus 2. And then the leftovers. X minus y. Either of those go further? Nope. And we're done. Now, I'm going to tell you right now that this type of factoring is very easy, I think, in the grand scheme of factoring. It's pretty straightforward. It is the most missed type of factoring when we get into solving. Because you know what people do? They do this first step, and then they tell me their answers. Well, let's go back to like this one. People do this, and then they're like, they set 4x squared equal to 0. They set x plus 3 equal to 0. They tell me -1's an answer, and they set x plus 3 equal to 0. They like do the first step of it, and they don't actually finish factoring it. So make sure when you're doing this, you better have at least 2 lines in your work when you're factoring these, okay? Pulling out GCFs and then moving into factored form. Your factoring should be 2 sets of parentheses, okay? It's the most missed when it comes to solving. Yeah. All right. All right, guys. The last new method of factoring. I like these. If you're a pattern person where you're like, I can just like follow the formula or follow the pattern and do what it says, you'll like these. There is no thought to these. It is just, you know the pattern, plug the numbers in. Okay? Just so you know. So this is not one that you're going to sit around and guess and check with. It's not going to happen. Okay? You have to know the pattern. But first, what are your perfect cubes? What's 1 squared or 1 cubed? It's still 1, no matter what I asked you. 2 cubed is 8. You're going to want to make sure you have this list, because squares we recognize, right? We see the squares and we know they're perfect squares. Cubes, probably don't recognize those. 1. Because that's 1 times 1 times 1. Keep in mind what we're finding here, right? 2 cubed means 2 times 2 times 2. So what's 6 cubed? That is 216. She already probably worked ahead. 7 cubed? I, on the other hand, do know these. Yeah, I do these too often. Three zeros. Yep. All right, so those are your perfect cubes. Recognize them, learn them, know them. Now, obviously, if I would be like, you must memorize all these perfect cubes, you have a calculator in front of you. You could make the list at any given time, right? Do I have a song? I do not have a song. That's good. That's good. We need to come up with a song for the cubes, right? All right, but just I wanted you to see them, to recognize them, so they start to kind of jump out at you, okay? Now, obviously, that's only the cubes through 10 cubed. There's an infinite number of cubes, but those are the ones you see the most. All right, so here's the pattern. You have to just know the pattern. There's no guess and check. We got to know it. So we always had, let's come back to, we always did squares, right? It was always difference of squares, had to be a minus sign. Now, this is sum of cubes or difference of cubes. So it can be a plus or a minus, does not matter. Okay? And if you memorize my pattern, then you'll be fine with figuring out what all the signs are. So first, take a look at how these are both separated. Both numbers are cubes, just like we both had the squares. Both numbers had to be squares. I can do it with a plus or I can do it with a minus. Now, soap. You guys know I'm a germaphobe anyway, right? Please use soap. Okay? Helps you remember how to do this. Although I gotta say, you ever in the bathroom and you hear somebody come out of a stall and they walk out the door? I sit there and like cringe, like, oh my God, like you just went to the bathroom and you didn't even like pretend to wash your hands. Like you just walked out. Or you ever hear the people that turn on the water, but you're like, you're not really washing your hands. You totally know. Yeah, you can tell. You can tell the difference. So if you're that person, start using soap. Don't pretend it. Don't walk out without washing. That's disgusting. You're laughing at me, but it's true. You know what happens. It does. But anyway, the whole reason I bring up soap, right? We talked about toilet paper with square roots, right? Now we're talking about soap. So, same sign, opposite sign, always positive. That's how we remember this. Soap, same, opposite, always positive. The way they split, normally we have two terms and two terms, right? Binomial and binomial. This one's different. We have two terms and then three terms. It's the first time we've ever seen this happen, okay? So when we're doing our signs, the first one is always the same as the problem. Then it's the opposite, so a plus, the opposite of plus is minus. And then the last one is always positive, no matter what. Okay, so over here, same sign as the original problem, then it flips to the opposite, and then that one's always positive. Yep, no matter what. That's what our signs look like. So we're just talking signs, right? Because whenever we factor, that's the first thing I always ask you, what are your signs? Okay, but I want you to recognize it's two terms and then three terms. We've never seen that before. All right, so that's how you fill in your signs. So, and then down here, when you factor this, guys, recognize the pattern. Just like in square roots, the first thing we did was take the square root of both. That's what happens here, but the cubed roots. So if this was my problem, look at my signs. Same sign as the problem. It flipped to the opposite, and the last one's always positive. If this was a cubed plus b cubed, you would take the cubed root of each. That's what goes here. So if that was an x cubed, you would write an x. If this was 27, you would write 3, because the cubed root of 27 is 3. On the calculator? If you were on the graphing calculators, if you hit the math button, it's right underneath green. If you hit math, cubed root is option number 4. Okay, so if you're on the graphing one, it's math, which is underneath the green button, and then option 4 gets you cubed root. If you are on a scientific calculator, you have to hit 3. You have that one on there. Somebody's got a scientific one? Somebody close to me who already has one out? Thank you. So on the scientific ones, you have to hit 3 and then second caret. 3 second caret on those. So 3 second caret. That'll get you your cubed root. And then you can type in the number. Yeah, so it'll look like 3 and then an x like this. Yeah, it's telling you that x is the cubed root. That's what it's telling you. If you're on the other one, it's math button and then option number 4. I don't know. It's got a mind of its own. Okay, so depending on what calculator, if you want to hit the cubed root buttons. Okay, so that's how you get the first part. And then it's square, multiply, square. So literally, once I get these numbers, I don't care about that anymore. I'm using this first set. I'm going to square the first number. See, a turns into a squared. Then I'm going to multiply these two together, a times b, whatever that answer is. Then I'm going to square the last one. So square, multiply, square. It's like I'm doing the first, them together, and then the end. Square, multiply, square. Yes? Mm-hmm. Cube root it? Yep. You shouldn't. Then yours was probably a GCF to begin with. All right, so guys, when you're looking as far as here's your whole page of factoring, how do I recognize these? One, take out GCF. And sum of difference of cubes is only 2 terms. So if you have 2 terms, it's either going to be squares or cubes. That should be easy to recognize, right? So cubes is you have to memorize this pattern. All right, so is there a GCF here? No. So let's set up our parentheses. Remember, the second one's going to be a little longer because it's going to have 3 terms in it. We need to make sure we use our SOAP. So same sign as the original problem. So it's going to be a minus. The opposite of minus is plus. And then AP stands for always positive. That last sign is always positive. So that would be the first thing I do every time is I set up my parentheses, use my SOAP. Same, opposite, always positive. Then let's worry about our numbers. So what is the cubed root of 27x cubed? 3x. Don't lose your x. All right, so we did the cubed root. All right, I just want to make sure that's cubed root of 27x cubed. That's where that came from. This number is the cubed root of 8, which is 2. Once you fill in the first set, I don't care about the original problem anymore. Because this is going to be square. So what's 3x squared? 9x squared. Then you multiply both of these together. What's 3x times 2? Notice I didn't care what the sign was. I already put my signs in from the beginning, so I don't worry about it. And then square the last one. What's 2 squared? Done. And let me tell you right now, you may look at that last part and be like, oh, I can factor that further. No, you can't. Ever. You cannot. So don't try. That is always how you finish. I promise you, the last one will not factor, okay? Students try every year, over and over. They get so mad, it doesn't factor. When we're solving, you will have to use the quadratic formula. I love that you picked up on that, though. Yeah? Multiplying the 3x and the 2. Yeah, you're literally going square this one, multiply the 2 together, and then square the last one. So you use the first one, you use them together, and then you use the last. It's kind of like a little pattern, right? All right, so let's do number 18. Is there a GCF? No. All right, do you recognize that it's cubes? 2 terms, and there's an x cubed on it. Okay, it's cubes. All right, so let's set up our parentheses. Second one's a little longer. We fill in our SOAP. Students usually just refer to this as the SOAP pattern, right? Because they get used to seeing that. So what are my signs going to be? Same as subtract. And then opposite, always positive, plus. So fill in your signs first. Now let's fill in the numbers. What's the cubed root of 125x cubed? Cubed root of 1? 1. You with me so far? Okay. Don't scare me like that. Because every year there's somebody who's like, I just don't get it. Somebody always does it, okay? If it's you, that's fine. Just tell me. Okay, good. All right, and then over here, square, multiply, square. So square the first, 5x squared. 25x squared. Multiply the 2 of them together. It's 1 squared. I am done. Yes, I do. Take the cubed roots and then square, multiply, square. Not that hard. It really is. Thank you. The grouping. You didn't like the actual normal guess and check factoring that we've been doing all semester? You just don't like all the extra variables. Gotcha. I don't give you extra variables all that often. All right, you ready to try the next one? Next Friday. All right, 19. GCF? No? There's a plus sign. Is that okay? Yeah. Sum and difference of cubes. You can use either or. It doesn't matter. So if we set up our parentheses, use SOAP, same, so it's going to be a plus. Now it's the opposite, which is a minus, and then always positive. So if you use SOAP, signs should be easy. Same as the original problem, then the opposite, and then always positive. Okay? And then how do we get these first numbers? Cubed root. What's a cubed root of 8x cubed? I have students every year who have parentheses full of numbers and not a single x in it. Wrong. I do take points off for that. All right, cubed root of 1. This is fun stuff, right? And then we square 2x squared, 4x squared. Multiply 2x times 1 is 2x, and square. We are done. Yep, I'm multiplying these two. So you square this one, then multiply them, and then square that one. All of these numbers are coming from here. I multiplied 2x times 1.
So how would this right here, how would that 3 times 2, how would that positive 6?
We filled in our signs from the very beginning. That's why I fill those in first. So when I multiply, I ain't even looking at any of that. Also, you can think about it. If I did multiply 3x times negative 2, this sign is always the opposite of what you're getting. So if I fill in the signs first, I ain't got to worry about it. I know what they are. No. The first one's always the same as the original problem. This was a plus, so my first one's a plus. Is always a plus. The last sign's always plus. This one's always plus. Same sign, opposite. This one will always be the opposite of what this one was.
So the first sign in this problem is always opposite.
It's always the opposite of what this one was. Yep, that's why it's same, opposite, always positive. Now, is anyone else like intrigued by how does that work? Like if I multiply that back together, would I really just get 8x cubed plus 1? Does it seem weird that that would really work? Just for giggles, let's look at it. So if you multiplied this back together, just for giggles, it's fun, right? That would give you 8x cubed minus 4x. And you don't have to write this down if you don't want. Yes, thank you. That would be plus 2x. Distribute here, 4x squared minus 2x plus 1. So I put in like terms, I have 8x cubed. What happens to your squareds? They're gone. Your x's cancel, and I have plus 1. So could you check your answers if you're like, I'm not sure if I did that right? Yeah. It's kind of cool, right? So that's why your signs have to be what they are, the same, opposite, always positive. Bless you. Why don't you guys try number 20 on your own? All right, guys. Was there a GCF? No GCF in this one. I've thrown too many acronyms at you today, right? All right, how do I know my signs? So, same, opposite, always positive. Cubed root of x cubed. Cubed root of 343. Square, multiply, square. What is x squared? Multiply. Square that one. Will this factor further? No, it never will. Stop trying. No, it won't, ever. I promise. Don't waste your time. No. All right, questions. We looked at quadratic, which we've done before. Quartic, which act like quadratics. Just don't forget x fourth becomes x squared, x squared. Then we looked at grouping, has how many terms? Has 4 terms. Grouped first 2, grouped last 2, right? Called GCFs. And then we talked about the cube pattern. Yes? Good? Question? Are we live today? You guys look like... Almost. Not yet, though.